Hi everyone, my name is Mark Stewart. I'm from the northeast, not too far from Aden actually. Very quickly about me, because I realise it's already touching 5 o'clock, is I've worked in FE for about 15 years, head of maths for most of that, and a couple of colleges in the northeast. About a year ago, I started working for a company that Emma kindly mentioned a little while ago called the Development Wheel, and we are running in some DFE funded training, almost like a SafeM 2.0 or 2 Point Better, to colleges up and down the country. So get in touch if you're interested in any of those. For now, though, I will talk about something which I think is often an understated and undervalued concept within teaching maths, and that is automaticity or fluency. I'll use both words, which I think is really an important way for students to be able to develop those reasoning problem solving skills, but that we know they lack so much. So in the interest of time, because I always chronically run over, I will get a move on. There we go. So if you ask a psychologist, a neurologist what automaticity is, they would say it was some kind of automatic response pattern or a habit. In terms of maths, though, I think it'll be a little bit more specific, and I've thrown some words together here. I think it's an immediate, effortless recall of arithmetic facts or formula, process, whatever you want to call it, and the ability to apply them timely. And the key words there are really that immediate, effortless recall, because it is so important. My clicker stopped working. There we go. There is a much wider issue, and this goes right back to primary school. So learners in primary school, it's through the research, I'll share some references at the end. Learners in primary school start already at that young age to sort of differentiate between learners who get it, who understand maths, and those that don't. And it usually is just really simple mathematical facts and multiplication, division, place value, operations, whatever it is, factors, multiples. But students at that age, and I've got children in primary school, and I've heard my youngest kind of infer things like this. They say the friends, they say the peers start to succeed, and they don't, because they've started to already, sort of tangentially drift apart. And they, at a very young age, think maths is not for them, that it's too difficult, that it's some sort of archaic, almost magical thing that other people are allowed to do and they can't. And for them, that pattern of failure and disengagement starts at a very young age. I think that's very sad. And that exacerbates, and by the time they get into schools, the school system, the secondary system, they can be already 2-3 years behind their peers, and the school system really isn't designed to catch that up. Students often get put into lower sets where they don't necessarily get the intervention or the support they need. I know that's a very sweeping generalization of secondary, but we've all heard those horror anecdotes of students describing lower sets in schools, and it is very not fair on them or teachers. I won't read these out, but there are some very clear research and some very clear correlations between the lack of ability to use automaticity or fluency in primary school and future mathematical understanding and progress. Essentially, if you start to differentiate, bifurcate at that young age, your ability to then reason and problem solve by the time you get into secondary school is already critically undermined. And there's a very clear correlation between that and being in these higher low achieving groups. And we're already at that young age pigeonholing students as to what they can and can't do, and that can't be right. Here's a question. It's adding 2 fractions. I'm not going to ask you to do it, but if I did, you'd probably do that in your head in probably inside 30 seconds, being the experts that you are. But actually, to a student who lacks that automaticity, lacks that fluency, this has got quite a lot of math facts, a lot of recall, a lot of things to know to do something which seems quite superficial. Now, this is a grade 1 question. My 10-year-old, my 11-year-old can already do this at school, and yet we know that this is a perennially difficult question for students who are 16, 17 in our classes. If you lack that automaticity, you will find there are up to 14 separate, distinct processes to do. And all the time that you were doing those, you've got to dredge those from memory, almost reinvent them back from first principles to be able to understand a relatively simple question. And they might get that over time, but that'll have cost them a lot of time. The question that you would do inside 30 seconds would probably take these students more like 3-4 minutes, if they were able to do it at all. And what's really happening here at the same time is there's a huge cognitive load on what are very finite resources for our learners. You turn that into some kind of written problem solving or reasoning question in an exam, and we know that students don't attempt this type of question. They've been overloaded cognitively. They see it, they recognize it, that stress, that flight anxiety creeps up. And we know questions like this get skipped. This is the question I wrote, but it's a pretty good explanation of questions. A lot of numbers in here. There's two separate fractions. There's a diagram. There's a part B. So students, by the time they even get to the point that just says add these two fractions together, and that's worth 4 marks. By the time they even get there, they're probably already switched off, and they're not going to have a go. If they do, if this is question 4 marks is 4 minutes in an exam roughly. Even a competent learner is going to take a good 5, 6, 7 minutes to attempt this question. So that automaticity, that instant recall, that effortless recall is so vital when it comes to succeeding with the reasoning and the problem solving side of maths. This rather random looking image. This was done by some research in America in 2010. And what this demonstrates are learners who were judged to have poor automaticity. They were put in fMRI machines, which is a bit harsh, but there we go. They were put in fMRI machines and they were asked to calculate questions, maths questions, which involved a lot of recall. Okay, so this wasn't even reasoning or problem solving. These were just questions that involved a lot of facts and a lot of recall. And I'll just clean that up so you can actually see it. Now, I'm not a neuroscientist, but I'm told that this demonstrates a lot of brain activity. And where that brain activity is, generally, is in the prefrontal cortex at the top of the brain. And that's the bit that suffers from cognitive load. That's the bit where your head starts to hurt, when you're really trying to focus on working out a question. The brains of these learners are essentially struggling. Contrast that with learners who were judged to have good automaticity, answering the same questions in the same format and the same research, and their brain activity drops to this. And that's very low. There's this very stark contrast there. The images across the bottom there, there's a little bit happening in the frontal cortex, but essentially what's happening there, they are activating memory areas of the brain. So they're allowed to bring that forward very effortlessly, and there's very low demand on their prefrontal cortex. In other words, that cognitive load has been reduced so much that they're able to focus and concentrate on what's actually important, which is the problem solving side of the problems. I think that's a very dramatic illustration. It's not that we want learners to not work hard and focus and be using the brains, of course not, but what we want is for them to do that at the right time and in the right process, and to have those reserves of energy left for when it is important, either in the learning and classroom or in exams. So we're essentially asking, can they reserve that cognitive effort, that reserve of energy and focus for questions like this on the left, and not the simple stuff on the right, which we should be able to accomplish via this automaticity. I'll not read the code verbatim, but it's essentially saying leave that prefrontal cortex free so it can do the heavy lifting when it's required, that reason and problem solving, so that it's not just about automaticity as in recall. It actually helps learners to understand the concepts. It's linked to a mastery approach. I'm not sure if mastery is a subset of automaticity or automaticity is a subset of mastery. Don't want to start some sort of Harry Hill fight here, but they're both absolutely vital. And it's about reducing and managing that cognitive workload, because that work and memory is a very finite resource for students, and especially when they're in exam conditions, stress starts to take over. They get that fight, flight, freeze response. And the first thing that goes is your work and memory when you're in that response situation. The benefits to reducing that cognitive load is that it actually deepens understanding. If you are not having to stop and reinvent from principles how you find the lowest common denominator when you're adding fractions, if that happens automatically and effortlessly, you can understand maybe why you need to find a common denominator. So you can actually spend your precious resources, your energy, your focus, and the time working on the things that actually deepen your understanding. So it's very different from rote learning. It reduces the cognitive load, like I've said, and frees up that working memory. Most adults have a working memory which limits them to being able to remember either a 5 or 6 digit number and multiply two digit numbers. We'd probably find that relatively easy, but to do that in your head is actually a really challenging task. And students, again, at that age, in an exam stress scenario, their working memory is vastly reduced. So we need to free that up as much as possible. The mental resources, as I said, need to be saved for those challenging problems. And the reason is pretty simple. 50% of the marks in your maths exams are from AO1 marks, that recall and apply. The other 50% are from AO2 and 3. So if learners are spending all their time, all their focus, all their efforts on re-establishing those AO1 skills because they lack fluency, they lack automaticity, then they don't have that time, let alone the effort or the confidence to work on the AO2-3 skills. Now, it's not a coincidence that the grade 4 boundary hovers around 60%. You can't get anywhere near really that boundary unless you are able to divert your time and attention into those AO2 and 3 area skills. It saves a huge amount of time, of course. If the fraction question, you can do that in 30, 40 seconds as it's meant to be done in an exam instead of 3 or 4 minutes. Compound that over 25 questions, that's a huge saving in time. The increased accessibility to those questions and the willingness to actually have a go at them is improved. And it allows learners to actually get down and focus on what that reasoning and problem solving question is, because the facts, the recall is effortless and it's immediate, as it is with us as experts. Their confidence is increased and their stress and anxiety is decreased. That stress reaction in an exam is the last thing that learners need. And hopefully what's actually improved above anything else is exam performance. So how do we promote automaticity? Well, essentially, we need time and opportunity to practice. I've got a couple of ideas of what that could look like. I'll share them with you. One, anybody who knows me in my practice knows I'm obsessed with flipped learning. I've been a practitioner of it for, well, many years now. We did it at the college I was at as a department. It is incredibly useful. It's incredibly impactful. One of the things it allows people to do is to, before the lesson, 2 or 3 days before the lesson, it allows learners to start practicing those skills and develop some level of automaticity before the lesson's even started. The approach that I want to share with you today is what we call this longitudinal approach, by using starter activities, and starter activities are the ideal vessel for it because they are consistent at the start of every session all week long, and they can be done in quite a short frame of time. So essentially, learners via starter will practice those AO1 skills, the skills we want them to have automaticity in, whether it's factors and multiples, being able to work with the 4 ops, being able to work with formulas. Area of a circle can be quite a conceptually difficult question, but it's even harder when you can't even remember the formula or how to substitute numbers into it. So that automaticity of AO1 skills is the gateway, like I said, to those reasoning and problem solving skills. In the session, we would immediately mark and give feedback. So they would have 10 minutes strict to attempt the questions that I'll show you in a second. And then there'd be a 5-minute phase where the marking and giving feedback was absolutely essential. And it is because what you want them to practice and be automatic with are correct solutions. You can practice and be automatic and still be incorrect, and that's very damaging. So we need to find the common misconceptions and those errors in their understanding via that marking and dialogic feedback. It's great for structure. Learner knows what's happening at the start of the lesson. They can come in and get straight on with that starter activity, and it warms learners up into that initiation behaviour to commence learning. And the results, we had a notebook where students could track the results over time, and literally by drawing a highlighter between the question numbers, they could identify whether it was week on week they were poor at algebra, whether they were poor at 4 ops, whether it was factors and multiples, whatever was causing them trouble. That can be easily identified, and then you can do something about it. So this is what it looks like. What it looks like is obviously irrelevant. It's the content. So we'd ask them set questions, 10 questions every session, so twice a week for 10 minutes. And there would be some basic number elements, some advanced number elements, some proportions, some algebra and geometry. Statistics deliberately isn't on here because we had other ideas about embedding statistics across the year. But you can see week 3, this is in the first week, learners are working on relatively simple skills. So just if you have a look at question number 4 there, it's just simplifying a really simple fraction. A few weeks later, 4 or 5 weeks later, same idea, but part of the research indicates that's very important to increase very slightly, manageably, the cognitive load, i.e. they should get harder over time. So if you look at question 4 now, it's adding 3/5 to a decimal. So learners then have to, through that level of automaticity that they've gained, turn 0.3 into 3 out of 10, turn 3/5 into 6 out of 10 and be able to add them together. And it's that combinatory effect of those simple fluent skills that they have is the real benefit to it. And fast forward another sort of 6 or 7 weeks, now we're moving into more complex territory, things like standard form and estimating roots and turning percentages of greater than 100 into a fraction. So learners really develop their skills very quickly over time. The results that we noticed from doing this, we did this as a SafeRem research paper. Actually, it's on the website if you want to have a look at it. It had dramatic impact on their exam results eventually. The performance in these starters, they all kind of complain at the start that it's too hard and they feel down about that, but actually very quickly within 2-3 weeks, their performance improves really, really quickly. And that huge confidence and resilience leap also because of that. Like I said, the misconceptions and skills gaps are the most critical part because you need to iron those out before you then cement that into long-term memory and that automaticity that we're looking for. It helps you to develop, areas for development can be action. So again, over time, if a learner just discovers from doing this, consistently, repetitively, week after week, that equations are causing them trouble, that it's always geometry, it's anything to do with angles, you can iron that out because suddenly you've got months to do that and you're not waiting for that topic to hit in your scheme of work. And just their ability to access and the confidence to answer those AO2 and 3 questions is massively improved. If in this beautiful sun that we're having, you're struggling to sleep at night, here are some fantastic references that will no doubt do the trick for you. Joint aside, some really, really interesting stuff in there from the ETF and all sorts of stuff. The second one down is a very efficient, very quick video that you can watch by Paul Chomsky. And summarizes everything far better than I could. Fascinating to watch. Please watch it. The rest of them also really, really good. Perfect for these summer nights. I'll pause and ask for questions as I exit out of this, and thank you for